This is Gib Jones. I'm your moderator today for session A7. The session's dam and levee risk education. We got three presentations for you. For those that aren't familiar with this format quite yet, the way it kind of works is that we'll be playing a presentation, and then each presentation will be followed by its own individual Q&A session. For the Q&A, go ahead and put your questions in the chat box, and you can put them in the chat box at any time. And then I will go ahead and read those questions out at the end of the presentation. And we'll get through as many of them as we can for each session. So with that, I'd like to go ahead and introduce our first presenters. We have three from the California State Department of Water Resources. They'll be presenting on State of California Model Floodplain Management Ordinances, Higher Standards, and Quick Guide. Kelly Soule is supervising engineer with California DWR and the state NFIP coordinator. Antoinette Duncan's a senior engineer and the CAP SASE grant administrator there. And Solomon Miranda is a senior engineer and floodplain management specialist for the southern region. And with that, I am going to hand it off to our presenters.
Good afternoon. Thank you for tuning in today to learn about California's floodplain management ordinances. DWR has been working on updating our model ordinances for a few years, but the timing was perfect to finalize them when the California Building Code was updated and the changes became effective on January 1st, 2020. We wanted to take this opportunity to share with you the resources that we have developed for California communities to utilize. First, I'd like to introduce you to our DWR National Flood Insurance Program staff that is presenting today. First, let me introduce myself. My name is Kelly Soule, and I am a supervising engineer and the California State NFIP coordinator. Next, we have Antoinette Duncan, who is a senior engineer and the CAP SASE grant administrator. CAP SASE stands for the Community Assistance Program State Support Services Element. This is the annual grant that DWR enters into with FEMA to deliver the National Flood Insurance Program within California. And next, we have Solomon Miranda, who is a senior engineer and a floodplain management specialist in our southern region. Because California is so large, California has established floodplain management specialists regionally so that communities can reach out to someone in their local region for assistance. As you can see by the map, California has been divided into 4 regions. We currently have 6 people in our region offices, and we have 5 people located out of our Sacramento headquarters. With California being so large, we certainly have a large scope of work to handle. We have 528 NFIP participating communities within California. Only 5 of our communities do not participate in the National Flood Insurance Program. We are also very lucky that we have such a high number of community rating system communities. There are 1,509 CRS communities nationwide, and California has 96 of those. There's only one state that has more, which is Florida, that has 244. Also, the CRS program only has one Class 1 community in the nation, which is Roseville, California. And we also have multiple Class 2 through 4 communities. We're very lucky that we have a state that has so many flood-savvy communities in it. What is DWR's role in the National Flood Insurance Program? We administer the CAP SASE grant by providing technical assistance to communities. We evaluate community performance. We identify, prevent, resolve floodplain management issues in the communities, and we conduct public education. Our public education consists of our statewide Flood Preparedness Week held every October. We also send approximately 300,000 direct mailers to residents in the floodplains within the Central Valley every September. We hold media events. We develop partnerships with local agencies, and we also hold NFIP trainings and workshops. The California Floodplain Management Model Ordinances were developed to help communities adopt local regulations that are written to work with the flood provisions of the California Building Code, CCR Title 24, for buildings and structures in special flood hazard areas. It is not mandatory that a community use these model ordinances, but it is recommended. The main times that a community will update its ordinances are during a community assistance visit, or community assistance contact, which would be conducted with either DWR or FEMA Region 9, during a community rating system cycle visit, or when there's a mapping project in the area. However, a community may elect to update their ordinance on their own at any time. We are here to assist California communities. That is why we developed these resources for the California communities to use that combine the requirements of the National Flood Insurance Program and those of the California Building Code. We have prepared many documents for the communities to use. First, we have the California Quick Guide, which is an overview of the National Flood Insurance Program requirements. Then we developed 2 sets of model ordinances, a companion ordinance and Title 24 Appendix G. The companion ordinance combines the flood provisions of the California Code of Regulations Title 24 into the ordinance itself. This companion ordinance contains everything necessary to fulfill the requirements of the National Flood Insurance Program. The Title 24 Appendix G, this is for communities that decide to locally adopt Title 24 Part 2 Appendix G flood-resistant constructions. This ordinance will modify that. Please note that Appendix G must be re-adopted each time the California Building Standards Commission adopts a new edition of the building code. We also developed 15 higher standards. These are for communities that adopt floodplain management requirements that exceed or are higher than the minimum requirements of the National Flood Insurance Program. Some higher standards affect the design of buildings, and others apply to development other than buildings. In addition to reducing future flood losses, some higher standards may qualify for credit under the community rating system. All of these ordinances have been FEMA approved and are coordinated with the California Building Code. Now, the California Building Code itself, Title 24, as I stated earlier, it was updated in 2019 and became effective in 2020. Just a couple of things we wanted to bring to your attention, some of the biggest notes for communities. The elevations for buildings must be built to the base flood elevation plus 1 foot in special flood hazard areas. This exceeds the minimum requirements of the National Flood Insurance Program, but it becomes the base condition for California because it is a California Building Code requirement. And again, if you're using Appendix G, you must watch for the readoption cycle by the California Building Standards Commission. The next cycle is in 2022 and it will start sometime in 2021. What is the process for using our model ordinances? It's quite easy. Just go to our website at water.ca.gov/NFIP and download our templates. Then you are going to update your ordinances per the instruction sheets. And then you'll be working with either DWR or FEMA Region 9 if you are within our region. And you're going to send us your updated ordinance for review at least 8 weeks prior to you planning to take it to your council. You're going to incorporate any comments that DWR or FEMA provides. Then you're going to adopt the ordinance at the local level, and then you're going to send DWR or FEMA a finalized copy for our records. For contact information for us, here are the email addresses for both California DWR as well as FEMA Region 9. And again, our website where all of the templates can be found is at water.ca.gov/NFIP. And with that, I'm going to turn it over to Solomon Miranda, who's going to present on the California Quick Guide. Thank you.
Thank you, Kelly, and thank you all for joining. I'm Solomon Miranda with the California Department of Water Resources in the Southern Region Office in Los Angeles County. Without a doubt, this past year has been challenging in so many ways. The pandemic has affected our personal and professional lives, our businesses, our schools, and our entire communities. But perhaps one of the unintended consequences of the pandemic is seeing the high number of retirements, layoffs, and a staff turnaround within the floodplain management community. Consequently, the need for NFIP training has increased. And one of our missions here at California DWR is to provide just that, training and technical assistance on matters related to the NFIP to over 500 communities around the state. One of the training tools we provide to our communities is the Quick Guide, to help local officials and citizens understand why and how California communities must manage development in floodplains to protect life and property. The quick guide starts by telling the reader how the NFIP works by outlining its main components: the Code of Federal Regulations, floodplain mapping, flood insurance purchase requirements, and mitigation. The guide also talks about the partnership among federal, state, and local governments, and describes the roles we all play in the NFIP. For instance, FEMA is responsible for producing floodplain maps, the state conducts community assistance visits and provides technical assistance, and the community is responsible for regulating development in the special flood hazard areas. To increase resiliency against future flooding, we encourage communities to consider incorporating in their local plans and floodplain management ordinances mitigation strategies that include goals and objectives to divert development outside the SFHA, to require freeboard above the minimum standards, to include flood risk disclosures to potential homebuyers, to minimize pluvial flooding by improving local drainage systems, and to include adaptation strategies for sea level rise. The quick guide also introduces the flood insurance rate map and flood zone definitions for riverine and coastal flood hazard areas. It also has information about the flood insurance study, floodway data tables, and flood profiles. And it gives a brief descriptions about the levee certification process. This section also introduces the letter of map changes, like LOMAs and LOMARs, and it explains when to use them and what forms need to be submitted. We've heard that 25 to 30% of flood insurance claims are in areas outside the SFHA. We all know that floods don't stop at a particular line on a map. Therefore, before approving new development, the guide makes a pitch to communities to consider freeboard and consider incorporating open space and setbacks from the SFHA for future subdivisions, and to consider restricting the use of fill material as it could impact drainage and affect adjacent properties in the environment. It also makes a pitch to consider restricting development in the floodway. However, if allowed, make sure that a no-rise certification is submitted. The guide also outlines the duties of the local administrator, like reviewing applications, reviewing plans, making sure that the lowest floor elevation is about the BFE, ensuring that all other states and federal permits are obtained, and issuing or denying permits. The guide has a section that introduces the FEMA elevation certificate and when to use it. First, the EC is used for compliance, to make sure that the lowest floor elevation meets the minimum CFR requirements, building codes, and community's floodplain management ordinance. Second, the EC is currently used to rate flood insurance policies. However, it will no longer be required to rate policies under Risk Rating 2.0. Third, the EC supports the letters of map amendments and letter of map revisions based on fill by showing that the lowest adjacent grade elevation is at or above the BFE. Last, using ECs for new and substantially improved structures is a requirement for communities participating in the community rating system. Next, the quick guide describes the NFIP requirements for different flood zones and different foundation types. In addition, it talks about requirements for flood venting, enclosures, machinery, equipment, and utilities. It briefly discusses the requirements for accessory structures, agricultural structures, manufactured homes, and recreational vehicles. This document also describes the substantial improvement, substantial damage that's referenced, and briefly describes how to calculate the cost of improvements and the market value of the structure. The guide also talks about substantial damage estimator, which can be used to assess flood, wind, wildfire, seismic, and other forms of damages. The estimator provides timely determinations so that reconstruction can begin following disasters. The quick guide provides some ideas to mitigate the risk of flooding, such as building flood walls and berms, or take more aggressive mitigation measures like addressing repetitive lost properties through acquisitions. For large-scale mitigation projects, we provide a link to the Governor's Office of Emergency Services, which administers the Hazard Mitigation Grant Program in California. Next, we introduce the Central Valley Flood Control Board, which is a regulatory agency responsible for issuing encroachment permits in the Sacramento and San Joaquin River basins. They enforce a higher regulatory standards for new development, such as setbacks from floodways and urban levee design to withstand the 0.5% annual change probability. As far as safety and preparedness, our Division of Safety of Dams provides oversight to the design, construction, and maintenance to over 1,200 dams. Our Division of Flood Management is responsible for roughly 1,600 miles of levees in the Central Valley, and our Flood Operations Center manages the state's flood emergency response and all local requests for technical and emergency assistance from the Army Corps of Engineers. If you've been following the water news lately about the Southwest, you probably know about our drought conditions, not only affecting our water supply, but also increasing our risk to wildfires. Having burned watersheds before any rainy event is a recipe for disaster, like the one we experienced in Santa Barbara County a few years ago. The Thomas Fire, which started on December 4, 2017, burned nearly 282,000 acres. A month later, on January 9, 2018, a storm brought significant amount of runoff above the city of Montecito, where 23 people died and dozens of homes were destroyed by the debris and mud flow. Our office maintains situational awareness year-round for disasters. However, pre-disaster mitigation for flood after fire events is necessary and will definitely require the continued support from our federal partners. Finally, we provide a list of resources if people need more information about the NFIP. And with that, I would like to thank you for joining this session. And now I'll pass the presentation to my colleague, Antoinette Duncan, who will talk to you about the new and improved California Floodplain Model Ordinance.
Thank you, Solomon, and hi everyone. My name is Antoinette Duncan, and I will be giving you an overview of the updated model ordinances that are available to assist communities in updating their ordinance to meet the California Code of Regulations, CCR Title 24, and the NFIP. These were developed by DWR and approved by FEMA Region 9. There are two sets of model ordinances available, a companion ordinance for coastal communities and one for non-coastal communities. We also developed a model ordinance for those communities who plan on adopting Appendix G. I'd like to take a few minutes to provide you information on where you can find these documents and other NFIP resources. Go to water.ca.gov/NFIP to find California NFIP resources such as the California Quick Guide that Solomon just discussed. Scrolling through the NFIP pages, you will find a section for the California Model Ordinances, and you will find that it includes resources to help communities update their floodplain management ordinance to ensure they are meeting not only the NFIP standards, but also the California Building Code standards. You can also send us an email at dwr_NFIP@water.ca.gov. Within the General tab, you will find frequently asked questions about the 2020 California Building Code Coordinated Floodplain Management Model Ordinances and the 2019 CCR Title 24 flood excerpts. Under Zone A for non-coastal communities, and under Zone A and Zone V for coastal communities, you will find individual California model ordinances for each, instructions and notes, and the model ordinance cross-reference check tool. There are instructions that go with each of the model code companion ordinances on our NFIP website. But if something is unclear, you can always email us with questions. The model code companion ordinance for Zones A or for Zones A and V should not be used if the community is going to adopt Appendix G, and the model ordinance is specifically written as a companion to CCR Title 24. Also note that the model ordinance does not include any higher standards that affect the design of buildings. There are a total of 15 articles, and the following are different in the model code companion for Zone A compared to the one for Zones A and V. And between the two model code companions, these are the articles that are different. The purpose of this slide is to give you a comparison of the two model code companions available. You will notice that under Article 104, permits for floodplain development for non-coastal communities, there will be less permits required. But if you look under Section 104-4 for zones A and V, you will find that there are additional permits required under the California Coastal Act. Some key information I would like to point out to you from Title 24 Appendix G instructions and notes are the following. The Appendix G should only be used if the community will adopt the optional California Building Standards Code CCR Title 24 Appendix G. And also it is important to know that the ordinance must be readopted every 3 years. Included in Appendix G are floodplain administrative responsibilities, administrative provisions, frequently asked questions, and higher standards. There are 12 articles included in the Model Code Companion Floodplain Management Ordinance within Appendix G, and they're listed on this slide. We also have resources for communities to adopt higher standards. There are currently 15 higher standards for floodplain management, and a few of them include freeboard, repetitive losses, flood hazard maps other than the firm, and a benefit to adopting higher standards is that it may enable a community to qualify for CRS points, and it may reduce your flood risk and insurance premiums. Here are a few tips to help communities update their floodplain management ordinance. Tip number 1, download your template and instructions to go with your version. Tip number 2, please use the track changes when updating your ordinance because this will make the review process easier. Tip number 3, carefully read the instructions before filling out the community's information. Tip number 4, leave your renumbering until the end of your text edits and use the cross-reference check tool and the crosswalk to help with this process. Send your draft ordinance. Tip number 5, send your draft ordinance to DWR staff or FEMA Region 9 for review. The crosswalk that I mentioned earlier lists the NFIP regulations and demonstrates the model ordinances is consistent with the NFIP. This will be helpful when your current model ordinance this will be helpful in identifying where your current model ordinance deficiencies are and help you determine if it would be beneficial and is needed to update your community's model ordinance. The crosswalk includes definitions from the federal regulations and from the California Building Code. It also lists each NFIP regulation and identifies a section in the California Model Ordinance and the CCR Title 24 California Building Code. During our community assistance visits, our team uses this crosswalk to review communities' ordinance and identify deficiencies. For example, a community must include language in their floodplain management ordinance that adopts or references the correct flood insurance study and date. The crosswalk identifies this in the California Model Ordinance Code under Section 102-2 and where it is covered in CCR Title 24. Another great resource is the cross-reference check tool to help you renumber your section. After the model ordinance has been revised and tailored to your community, then renumber your sections and use this cross-reference check tool to do so. So why use the state model ordinance? One reason is the California Building Code can have more stringent requirements than the NFIP regulations. For example, in A zones, the NFIP requires the lowest floor to be elevated to the BFE or above. The California Building Code requires the lowest floor to be elevated to the BFE plus 1 foot as a minimum requirement, as you can see in this illustration. The state model ordinance also meets the NFIP requirements and is coordinated with the California Building Code. and this will help the communities ensure they are following both federal and state regulations and reduce the risk of buildings in flood hazard areas. Another reason is they were developed by California DWR and they're approved by FEMA. And finally, California communities are required to adopt California building standards within 180 days after being published. We are excited to finally be able to share these with our communities. So please email us with questions. We are here to help our communities. And we thank you for your time, and I hope you enjoy the rest of your conference.
Okay, hello folks. I hope everyone enjoyed the presentation. This is our opportunity to ask any questions you might have. If you do have questions, please go ahead and enter them into the chat, and I will go ahead and read those off for our presenters. We have all three of our presenters here, Kelly, Antoinette, and Solomon, are available to answer any questions you might have. So go ahead. I haven't seen any come through yet, but there's a little bit of a delay. So if you type something in, it might take me a little bit before I see it. But go ahead and enter any questions you might have, and we'll pass those on to our presenters. Okay. Well, we did just get one question that's come in. The question is there a deadline for when communities need to adopt the model ordinances as their own?
No, there's not.
No deadline.
No deadline. Most of the communities will go ahead and work on the model ordinances either when they are having one of the community assistance visits or when they're doing a mapping ordinance. But there's not a firm deadline that they have to have it in place as far as I'm aware. Solomon, Antoinette, jump in if I've missed anything there. I do know we were working with one community that they had to meet a deadline on. But there was a very specific reason.
Yeah, great point, Antoinette. Might I chime in real quick? If a community is about to adopt new maps, it has to be effective before those new maps come out. And whenever we have a CAB with a community, normally we work with them because we know this might take a few months to go through city council and get it approved. So there's those kind of deadlines. But if a community has a compliant ordinance and wants to adopt the building codes and merge them together, there's no deadline for that. You're right, Kevin.
Thanks. We did get another question. If someone is in another state, would looking at the California model ordinances be helpful?
We think so. Obviously, you're going to have to tailor it for your own state, make sure that you're meeting your own building code requirements, and work with your FEMA local region office to make sure it's compliant. But it's going to give you a good basis for someplace to start. I'd also like to plug in today, too, that on Friday, there's a workshop with Rebecca Quinn, who is going to be going over code coordinated model ordinances. She is the consultant that we worked with as well on this. So definitely, if you are interested in working on your model ordinances, try to plug into that workshop on Friday with Rebecca. But we do think it is helpful. It gives you a good starting base to start with.
Excellent, thanks. All right, one more. Levees and dams changed the flood risk confirmed maps. Do you believe that risk is truly averted with these mechanisms, especially with the probability of failure of these mechanisms?
Sorry, I'm reading that again here.
Yeah, levees and dams changed the flood risk confirmed map. Do you believe that risk is truly averted when these mechanisms, especially with the probability of failure of these mechanisms?
I don't think that the risk is truly averted, but it certainly reduces the risk. That's what I can say. Levees and dams, they absolutely mitigate some of the risk. But we can't truly avert all of the risk associated.
When floodplain management and planning was explained, one of the strategies was, quote, improve local drainage. How do you estimate which are the critical areas where you have to focus?
That's a great question.
Thank you,
Go ahead.
Solomon. No, I was referring to you.
That's a great question. As you know, the firms do not map pluvial rain events. So most drainage systems in the community are designed to a 10-year frequency. So you're basically we advise that local mitigation could be a way to mitigate for future floodings by improving your local drainage system, I guess, because communities know best, obviously, and hopefully within their infrastructure they can apply for grants to improve that system. That will help them tremendously.
All right, why don't we hit at least one more? Southern California reviews ordinances in conjunction with other codes, building codes, Clean Water Act, etc. How many different related codes have to be reviewed, and what are they?
Oh, that's a very good question. I'm not aware of that. In our, I only know about the residential code and obviously the building code, the mechanical code. There's a lot of codes, but the ones that intertwine with floodplain management, and Antoinette, please join in this conversation if you have the right answer. How many codes? But to my knowledge, there's only the residential code and the building standard code.
We have one other, and hopefully it's a quick one. Our dams and levees.
I wanted to just chime in also that, yes, I agree. I don't believe there's any other codes besides the ones that Solomon mentioned. I'm not aware of any others that deal with the floodplain management.
All right, thank you. One other quick one. Are dams and levees, permitting considerations of building below the dam or behind a levee, are dams and levees mentioned in your model ordinance? Anyone want to take a crack at that one? We'll have to wrap up our Q&A with this last question.
I don't believe that we specifically call them out. Trying to remember here, I haven't looked at them in a hot minute, but I don't think we specifically call out dams and levees. It's more just general floodplain management. But again, if anybody has questions, feel free to email us. We can send you the documents. They're on our websites, and we'd be happy to walk through any other questions or concerns anyone has.
Great. Thanks. I think we should probably move on to our next one. Sure, absolutely. Our next presentation is the North Carolina Dam Monitoring Gauges and Alert System. And we actually have two presenters for this, Tom Langan and Gary Thompson. Tom is an engineering supervisor with the North Carolina Emergency Management Risk Management Section, overseeing projects related to digital flood insurance rate maps and database production, multi-hazard probability assessment, and other research projects related to risk management. Gary Thompson is the Deputy Risk Management Chief for the Risk Management Section of North Carolina Emergency Management, as well as the Chief of the North Carolina Geodetic Survey.
Good morning, everyone. I'm Tom Langan with the North Carolina Emergency Management, and today Gary Thompson and I will be talking about our new project for developing rainfall runoff models, installing new gauges at state-regulated dams, and how we will leverage this data within a dam alert and monitoring web application to support emergency response activities. Today I'm going to provide a quick overview of some of the innovative projects we are performing within our agency, tell you how we will perform rainfall runoff modeling at dams, demonstrate some of the functionality of our dam alert and monitoring systems, and provide an overview of low-cost gauge equipment we will be using to monitor water levels at dams. After Hurricane Florence in North Carolina, the state legislature provided NCM approximately $12 million to perform 3 major projects, including $4.8 million for developing a dam alert and monitoring system for intermediate and high hazard dams, $5 million to perform flood mitigation studies, for all areas that we currently do not have flood studies, and $2 million to purchase and install new riverine and coastal water level gauges to support our flood inundation mapping and alert network system, or our FIMAN application. North Carolina Dam Safety completed rainfall runoff modeling of approximately 218 dams in the Neuse River Basin, which determined the amount of rainfall in a watershed required to activate auxiliary spillways, overtop and potentially cause a dam to fail. This information will be integrated into a dam emergency and alert monitoring system, which will provide emergency alerts to North Carolina Dam Safety first responders and dam owners when forecasted or observed rainfall at a dam or in a watershed reach critical water levels identified by the rainfall runoff model for an individual dam. North Carolina Emergency Management has recently completed rainfall runoff modeling to determine critical rainfall amounts to potentially overtop a dam for approximately 287 structures, shown here with the green triangles. The studies that Dam Safety completed originally in the Neuse Basin are shown with the black circles in this figure. The North Carolina Division of Department of Environmental Quality, or NCDEQ, Dam Safety Section completed dam overtopping analysis for approximately 286 dams, or 268 dams to date. The goal of this modeling was to determine the amount of rainfall required to overtop a dam so alerts could be generated using that information. 6 design storms were modeled, including the 25, 50, 100, 200, 500, and 1,000-year storm events. Only dams with a structural height of greater than 25 feet and a maximum storage greater than 50 acre-feet were selected for this analysis. To perform our overtopping analysis, we had to collect data for various locations, delineate watershed boundaries, develop stage storage and spillway rating curves, determine watershed parameters, and design rainfall amounts, and put all data in our internal rainfall runoff model for a dam. Data collected include as-built information from Dam Safety to obtain spillway, dam crest, and outlet information. Where as-built data was unavailable, this information was obtained through field survey. The latest national land cover data set was used for land use determination, and the NRCS Soil Survey Geographic Database was used for soil types for curve number infiltration calculations. We used the latest NCEM Quality Level 1 or QL1 or 2 LiDAR terrain data for developing stage storage curves and watershed boundaries depending upon location within the state. Watershed boundaries were delineated using a 3-foot or 10-foot digital elevation model developed from our LiDAR data and using the GIS ArcHydro software. The watershed boundary was delineated from the outlet at the downstream face of the dam, as shown in the figure at the lower bottom left here. Next, we delineated the longest flow path for the watershed using ArcHydro or other automated tools. Shown here in the yellow, the longest flow path was used for lag time calculations for our hydrology calculations. ArcHydro again was used to develop stage storage curves for the tributary watershed for our dams, starting at the normal pool elevation at half-foot increments. Spillway rating curves were then developed from as-built drawings or dam survey information at half-foot increments, starting from the normal pool water level at the dam. A standardized spreadsheet was created by our consultants to assist with developing rating curves for the primary and secondary spillways. An example is shown here in the figure on the right of one of our spillway rating curves for this dam we are reviewing today in Forsyth County. Watershed parameters for the rainfall runoff model were then determined. The SCS lag watershed lag time method was used to calculate the basin lag time from the longest flow path. The SCS curve number method was used for infiltration losses for all models, and NOAA Atlas 14 was used for the design storm rainfall amounts. Finally, a single watershed and reservoir rainfall runoff model was created in the U.S. Army Corps of Engineers HEC-HMS model, and all of the previous described input data was entered into our model. The SCS curve number method was used for model losses, and hydrographs were developed in HEC-HMS using the SCS unit hydrograph method and lag time calculations. The model assumed no base flow, and an SCS type 2 or 3 storm distribution was used depending upon where you were in the state of North Carolina, since 2 curves cover the state of North Carolina. Models were run for a minimum of 24 hours or longer for larger watersheds. Here are the results of the overtopping analysis for the Crescent Lake Dam, which did not overtop during a 1,000-year event. So if you look at the figure to the right, the top of the dam elevation is shown in red, and then the rainfall amount, or the storm frequency versus the elevation, can be seen in the blue line. And as you can see, the 1,000-year event got within 1 foot of overtopping this dam, but did not actually overtop the dam. So to determine for these dams where the actual 1,000-year storm event didn't overtop the dam, to determine when the dam would overtop, we're actually developing a Python script internally to perform that task. So basically, we're going to extrapolate the blue curve and to try and determine that rainfall amount that'll overtop the actual dam itself. And earlier this year, we purchased the Dam Watch application from U.S. Engineering for our dam alert and monitoring project. This application is a cloud-based application that allows us to develop custom alerts for individual dams based on forecast and actual rainfall amounts and our rainfall runoff modeling or real-time water level data from our low-cost sensors. Alerts will be triggered and provided to NCDEQ dam safety staff when water levels predicted by the HEC-MH model and rainfall amounts or the gauge water level are within 1 foot of overtopping the dam. This criteria is consistent with the majority of emergency action plans currently implemented in the state of North Carolina. By the end of 2021, we will actively monitor 555 dams with our rainfall runoff models and forecast our actual rainfall amounts provided by NOAA. And also 130 dams will be monitored using real-time water level data from our low-cost sensors. Additionally, we will be loading overtopping failure breach analysis boundaries and data, and the system will also have current NCM and USGS water level gauge data in the system. The Dam Watch application is a secure application with access managed by North Carolina Emergency Management and NCDEQ. After you log in to the North Carolina application, you will see the following screen. If you click on the structure icon, as shown here, you'll see all of the dams in the state of North Carolina that are in our system. And if you click on one of those structures, that is actively, dams with rainfall runoff models will have the watershed boundary displayed when a dam is selected within the application. Alerts are generated using the NOAA quantitative precipitation forecast or quantitative precipitation estimate data. And this is called QPF or QPE information. So if you click on the rainfall icon, you can obtain the current quantitative precipitation estimates in the vicinity of your watershed. The figure below shows the 7-day rainfall totals in the vicinity of this dam. And as you can see, there's not much rainfall has occurred in the past 7 days. If you click on this icon here, you can see the QPF data, or the forecasted rainfall data in the vicinity of your dam. And the figure below at the bottom here shows the current forecasted 7-day rainfall in the vicinity of our structure, which is between roughly a ½ inch to 1 inch of rainfall for the next 7 days. Finally, you also have the ability to see real-time water level data for USGS and NCM gauges. And you can see that by clicking on the following icon. This figure here shows, or this display here shows water level data for the last 30 days for a gauge near the dam we were just looking at earlier. And that's it for an overview of our dam alert and monitoring system. So now I'm going to hand things over to Gary Thompson to detail and describe what we're going to be doing and the types of low-cost sensors we're going to be using and where we are actually going to be doing monitoring using these low-cost sensors.
My name is Gary Thompson. I'm with the North Carolina Emergency Management. I'm the Deputy Risk Management Chief and Chief of the North Carolina Geodetic Survey. I would like to provide you information about the water level gauge phase of the project. We plan to install water level gauges at state or locally owned dam sites that are either high or immediate hazard sites. And you can see from the image here, the sites that we plan to install water level gauges are marked with a green triangle. Before I provide detailed information about the project, I'd like to provide you information about some of the work that we did on previous projects that provide us information for this project. We previously worked on a project with the Department of Homeland Security, which is, the project was the Internet of Things Low-Cost Flood Inundation Sensor Project. Purpose of this project was to develop low-cost gauges that could be utilized by local governments, state agencies, federal agencies, and the private sector to monitor water levels in streams, rivers, and other water bodies. As you can see from the picture here, Department of Homeland Security worked with 3 companies to develop their sensors. These were a combination of ultrasonic and pressure sensors, all solar powered. We were one of the teams that took part in this project and were provided sensors from each company, and we installed, operated these sensors during the test period and provided input and comments back to Department of Homeland Security and to the companies that made the sensors. This project involved installing gauges at different sites across North Carolina. We've received a total of 75 gauges, 25 from each vendor. We decided that at each one of our sites we would install a sensor from each of the companies so that they would be will have equal comparison. We'll all have the same conditions as we operate the sensors. We picked 5 test sites, and so at each test site there will be a cluster of 5 gauges, 1 from each company. Our 5 test sites were Boone, Winston-Salem, and a second site in Winston-Salem, which is near downtown, Goldsboro, and Lumberton. We picked the Boone area because of the different weather conditions there, different temperatures. Boone is in western North Carolina mountains. They get a lot of snow. They also have, we have more, I guess, more flash flood conditions. So we felt this was a good test site. Winston-Salem was an urban area. We installed the sensors at some of the smaller streams. And then the 2 sites in eastern North Carolina, Lumberton and Goldsboro, had been impacted by flooding from previous weather events, and we felt like this was a good area to install the gauges and test them. The Department of Homeland Security test project led us to North Carolina A&T State University, the Geomatics program, to develop our own test site. At our test site at North Carolina A&T State University, we were able to test additional gauges at the test site. So you can see here from the pictures some of the gauges that we're currently testing. The project was funded by the University of North Carolina Chapel Hill, the North Carolina Policy Collaboratory, and we're currently taking part in what we call Phase 3 of the Department of Homeland Security Low-Cost Gauge Project. We're currently operating 3 pre-production units, and they're actually part of our flood inundation map and alert network. Both the Department of Homeland Security project and our test site provides us very valuable information to support the current project we're working on to install gauges at different locations across the state. So as for our project timeline, we currently are working through all these different points in our timeline. The first step was to identify the locations to where to install the water level gauges. We used a variety of our data sets, our LiDAR, statewide LiDAR elevation data, our L imagery. We worked with local emergency management officials and other local officials to determine the locations to install the water level gauges. And then once we determined the locations, we determined what type of sensor we would use at each location. Was a site suitable for an ultrasonic sensor, or do we need to install a pressure sensor? Sites where we could install the sensor at an elevation that was higher than the overtop in elevation, such as a bridge or a walkway that had a clear line of sight view down to the water surface, we plan to install ultrasonic sensors. The other remaining sites will be installing pressure sensors. Once we determine the locations and what type of sensor, we prepared data for our field staff to do a site visit. The purpose of the site visit was to determine if our proposed location was the proper location. In some cases, after consulting with the landowner, it was determined that we needed to move the gauge location to be in a more safer location, and also in case of overtopping, it had a better chance of surviving and continue to provide us information. Once we had completed the site visits, we worked with the landowner to obtain approval to install a gauge. We're currently finalizing the purchase of the equipment and plan to start installation within the next 2 months. Once all the installation has been completed, we will perform surveys at each location to establish the North American Vertical Datum 1988 elevation of each of the gauge reference points. As I mentioned, to support this project, we have a lot of data here in North Carolina that will support this project and other projects. One is our statewide LiDAR elevation data set. Here in North Carolina, we have collected statewide LiDAR elevation twice. First was from 2001 to 2005, and then a refresh was done in 2014 to 2017. And now we're currently starting our third iteration. In 2020, the United States Geological Survey collected quality level 1 LiDAR elevation data in phases 1 and 2. And also for the first time, topography LiDAR elevation data was collected along the entire coast by NOAA. So this is a very valuable data set that we'll be using this project, but also other projects that we've used for, like our floodplain mapping program. And it's also used by other state agencies, federal agencies, and the private sector. The other project is our statewide imagery project. This project is funded by the North Carolina Wireless 911 Board. Imagery is collected approximately a quarter of the state each year. You can see that in 2021, the data was collected in eastern Piedmont, and in early 2022, the northern Piedmont Mountains area imagery will be collected. This is some of the products we prepared for our field staff before they went to do their site visits. These are 2 proposed sites where we were planned to install pressure sensors. And you can see the green triangles, the proposed location of the hardware or the sensor, and then the approximate distance or estimated distance of the sensor cable down to the water surface, water level. These pictures are proposed sites where we plan to install ultrasonic sensors. You can see the one on the left is a bridge where we install the sensor on the railing, and then the picture on the right is a walkway and a lake that we will install the sensor. In a previous project, we had collected UAV oblique imagery at 87 dams in 3 counties in North Carolina. And this information will be added to our statewide emergency response application, just another product that we're providing to help with emergency response. And you can see imagery was collected so that We'll have a 360-degree view of each location where we collected oblique imagery. That concludes Tom and I's presentation, and we'll now open it up for questions.
Great, thanks. That was a super interesting presentation. That was great, Tom and Gary. Folks, if you have questions, please go ahead and send them in. Put them in the chat box and send them along. In the meantime, we do have a question here for you, both Tom and Gary. The breach monitoring system looks great. Can you describe the outreach necessary for local emergency managers and dam owners to update their emergency operations or emergency action plans to include this information?
So Gary, if you don't mind, I'll take this question. So right now, we're still building our application. So we just finished our hydraulic analyses of our dams. So we're preparing data to load into the dam watch system. But once it's all set up, I'm sure we're going to be doing some meeting and training on the dam watch system with our local communities and also with dam safety. So we'll meet with the local emergency managers and also the dam safety to kind of outreach this application. But as far as integration into the emergency action plans for dams, I don't think this will be integrated. It'll kind of complement emergency action plans. That's kind of the goal. So that essentially, if you receive an alert from the system, dam safety would know we may need to go out and check out the system or this dam in the field to actually see if if this is a scenario where we might have a breach occur. Because this is just, as everybody knows who's created emergency action plan, is just one component of it. There's multiple failure scenarios typically addressed in emergency action plans. So this would just be for monitoring overtopping failure type scenarios.
Great, thanks, Tom. No additional questions yet. We got some time for questions, folks, so if you have some, go ahead and send them in. I'll give another 15, 20 seconds to see if anything comes in. All right, we did just get some come in. Community rating systems activity 630, which is for dams, requires that a member community provide a list of high hazard potential dams that can impact its citizens or structures. Have y'all developed a method to provide this information to the CRS communities upon their request?
No, not yet, but that's a good idea. So that will certainly, our National Flood Insurance Program team is integrated in actually our risk management section here in emergency management. So that's something we'll definitely bring up to our NFIP team to see if we can outreach this to local communities.
All right, thanks, Tom. Next question, do the sensors work off a cellular or LORA? LORA? Do you have any cost ranges for initial installation and data costs for other applications?
Yeah, so currently all the sensors we're using cell modems. And the cost, equipment cost ranges anywhere from $1,000 to $4,000. And installation costs from $1,500 to $4,000.
Okay, thanks, Gary. Any other questions? Give you 10 seconds for any other further questions to come in. Here's one. How many people monitor the dams?
So right now, the primary responsibility for monitoring falls on the dam owners, and also DEQ and emergency management will support where needed. So as far as how many people would be in our dam watch system, it could be local emergency management managers and their designated staff, and then also dam safety staff, and then obviously our staff here at the risk management section.
Thanks, Tom. The IoT sensors are proprietary. How do you get the data, and is it live data?
Yeah, so we currently use a system, one rain called Contrail. And so we've worked with the vendors to develop a protocol that we can bring that data into Contrail and then use that data in our flood inundation map and alert network.
Thanks, Gary. Is DamWatch app accessible to the public? Will there be any plans to send alerts to cell phones?
The answer is definitely no on that. It's not a publicly available site, and we can't provide that information to the public side. Right now, there would be no intent to do cell phone alerts with the application at this time.
Okay, thank you. Excuse me. Any other questions? How about 5 seconds for any other questions? Okay. All right, very good. Our next presentation is Dam Safety Signage Guidance, Promoting Public Awareness and Preventing Loss of Life and Property. Our presenters are Jim Maroukis. He's a lead associate with Booz, Allen and Hamilton, and Diane Castro, a senior engineer with Atkins. They'll be joined after the presentation by Preston Wilson, who's a civil engineer with FEMA, to answer any questions you might have. So with that, let's head to the presentation.
Good afternoon. Thank you for joining us today to discuss FEMA's Dam Warning Sign Initiative, Promoting Public Awareness and Preventing Loss of Life and Property. I'm Jim Maroukis from Booz Allen Hamilton, and I've been supporting James Denby and Gökhan Insi on the National Dam Safety Program in various roles over the past several years. We have Diane Castro from Atkins with us today, who has also worked with the program on a variety of efforts. Gökhan will join us for the Q&A after the recorded session. So let's get started. The intent of today's presentation is to provide a brief overview of the Dam Warning Signs Initiative, as well as a glance into some of the industry-leading best practices. So that we're clear, the work we're doing is focused on dam safety signage. There are other types of signs on and around dams, such as waterway signs and hydroelectric facility signs. This initiative does not cover those. We're in the middle of our work to complete the best practices document, which should be available in late summer or early fall. What we will present here are the preliminary results with more details to be included in the final document. As you see from the agenda topics, we will discuss the importance of consistent messaging and move into identifying risks and the dam components that could present the most risk to the public. Then we will discuss how to effectively communicate that risk. We will round out our discussion with the development of a robust safety signage maintenance routine. Beyond the graphics and wording on safety signage, it is important to maintain signs in good order for them to be continually effective. Lastly, we'll wrap this up with the session with about 10 minutes of Q&A. The Dam Warning Signs Best Practices Initiative aims to compile and publish best practices for standardized messaging and pictograms for dam safety warning signs. To do so, we have reviewed existing materials from leading industry organizations such as Army Corps of Engineers, Bureau of Reclamation, CDA, ANSI, ICOLD, and others. We then interviewed a variety of stakeholders, including dam owners, operators, and state regulatory agencies, to gain an in-depth understanding of the state of dam safety signage throughout the country. Through this, we will make a best practices reference document available to dam owners and operators to encourage greater use and adoption of these best practices across the nation. It's important that state regulatory agencies and dam owners operators have the same frame of reference when discussing the need for safety signage. Various stakeholders have told us that there's a real need for a standardized point of reference. Through the use of one consistent reference document, signage expectations will be communicated and use and application of safety signage will be enhanced. So one of the key pillars of safety signage emphasizes the importance of consistent messaging throughout dams regionally and nationally. Currently, when patrons visit multiple dams, they are met with varying levels of safety signage, as well as different messaging and symbols for the same risks. This lack of consistent messaging could lead to confusion, misinterpretation, and ultimately lead visitors to completely disregard the safety signage that is present. Our best practices document highlights the importance of adopting consistent messaging throughout dam facilities regionally and nationally to increase public awareness of dam-related hazards and risks. As the public becomes more familiar with safety signage, this typically leads to increased adherence to the safety elements they identify. Think of highway signs. Even if a sign is obscured for some reason, drivers know that a triangle-shaped sign at an intersection is a yield sign, and an octagon is a stop sign. Beyond the colors and words, the shape helps the public maintain awareness and act appropriately. Identifying and evaluating the types of risks found at dam facility is another pillar to ensure all visitors are warned against these risks. We reviewed guidance published by the Canadian Dam Association related to risk evaluation. Risks should be evaluated based on frequency, severity, the location of the risk, whether it's upstream or downstream, as well as the amount of access the public has to the risky area. We will discuss several structures in and around dams in a minute, and for each of these structures, these 4 areas should be evaluated and then prioritized. Overall risk reduction for the dam should be done in a holistic way. Too many signs reduces their overall effectiveness, so we must be targeted. Once the elements are evaluated, the risk should be classified into one of the 3 main safety signage categories based on the level of risk the danger presents. The 3 categories are listed on the bottom of this slide. Only those warning against the potential to cause serious injury or death should be identified as a danger sign, while those warning against the potential to cause minor injury should be identified with a warning sign. Areas with little potential for causing injury, but which would benefit from additional signage, should utilize information and educational signage. So once we evaluate and categorize the risks, then we should look at the specific components. Diana Castro is going to take us through various structures in a dam.
Yep, thanks, Jim. So when we started thinking about signage, we needed to identify those components of the dam where the signage was most critical, just like what Jim just said. And we found many safety incidents occurred in the following areas. At low-head dams where there are hydraulic rollers, there are also situations with rapidly changing water levels and sudden releases from dams where people could be at risk. There are dangers in the spillway, strainers, conduit openings. There are entrapment risks at those mechanical components of dams, and flow under locks and gates where people open gates and try to navigate through a lock system also had a higher incident of dam safety issues. Next slide. Yep. So effective communication was the main focus of effective safety signage. And to achieve effective communication in signage, we focus on three main concepts. The first one is the psychology of signage and understanding how individuals interact with and interpret the safety signage. The next one is to incorporate appropriate and compelling language into the creation of safety signage so that they're easily understood by everyone. And lastly, we focus on the graphic side of safety signage and the actual formatting and design best practices. So when we started to research effective communication, we found research on the psychology of warnings. Mark Green's research paper entitled The Psychology of Signage describes various factors that decrease the likelihood of an individual responding to a warning signs. And these factors include familiarization with the area, the appearance of the warning, the human response gap, denial that risk could happen to them, and dilution or pollution of signage, where you just have too much signage and people can't focus on those signs that are most important to their safety. So safety signage is much more complicated than just warning the public of a risk, and we need to consider the human elements in how people interact with, interpret, and react to signage. By identifying these elements and finding unique ways to mitigate the hurdles, we can improve communication with the public and encourage behavioral change from people visiting a dam. The second element to effective communication is choosing the correct wording and applying the appropriate language. In order to reach a broad audience and effectively communicate with dam owners of all ages, backgrounds, and education levels, it is essential that safety signage be written in an approachable proficiency. This includes simple and straightforward phrases, and it eliminates complicated vocabulary and elongated sentence structures. We need to get straight to the point and deliver that warning. Conveying the risk could also be urgent, so it's crucial to use strong and direct verbiage when conveying the severity of risk to the public. Phrases such as risk of drowning and death are clearly and concisely identifying the risk at hand. Lastly, the language of the safety signage should actually reflect the individuals who are regularly assessing the dam. If there are multiple predominant languages spoken in the community, it's really important to consider integrating this language into the signage in order to communicate with them. For instance, in areas where Spanish-speaking people are living, as well as tribal and indigenous lands, safety signage should accurately reflect the communities. The dam warning signs best practices document dives deep into formatting and graphic elements that are most effective at conveying risk on the findings from a variety of industry leaders. I think Jim mentioned a few of them earlier in the presentation. The elements include font, coloring, recommended text size for various distances, the layout of the sign, and lastly, which materials should be used in the construction of the signage. The main takeaways of these findings include using the appropriate colors like red, yellow, white, and black, limiting the amount of words to convey a message concisely, investing in strong and more resilient signage materials to avoid damage and repetitive replacement, and strategically positioning the signage so it's clearly seen. Throughout our dam warning sign stakeholder interviews, several participants also mentioned the use of QR codes to provide additional resources. This could include videos, news articles, and supporting research relating to the risk. Therefore, we will be incorporating a section on the use of technology within dam warning signs best practices document. next slide. There you go. The last pillar of safety signage is to develop a robust system for assessing and maintaining dam safety signage. While having effective, clear, and concise signage is a step in the right direction, the efforts are all for naught if the signs are damaged, vandalized, or stolen. After speaking with a variety of dam owners and operators, damage and vandalism occur on a regular basis. Therefore, it's essential to create a plan to regularly assess a facility's safety signage and maintain and replace the signs whenever necessary. Some individuals add these facilities' public safety plan or add it as an appendage to the dam's operation and maintenance program. Within these plans, it's important to include information on building back better. By identifying the patterns within the destruction or disappearance of safety signage, steps can be taken to mitigate these. For instance, if safety signage regularly fades due to direct contact with sunlight, the sign needs to be replaced with materials that are more resilient to fading, so that replacement of signs would become less frequent. And now I think I turn it back to Jim.
Thanks, Diana. As part of the assessment and maintenance process, another best practice is to have an inventory of the safety signage that is located on a particular site. This can be a Google Map image with the location of each sign identified, or as simple as a Word document with the location and type of signs. Whatever tool is used, these documents will help ease the identification and maintenance of safety signage on an ongoing basis. The recommendation to tie this review in with the public safety plan or operations and maintenance plan is to have a regular interval for review of safety signage. As an overall dam assessment occurs, signage should become part of those regular reviews. In conclusion, proper dam safety signage can reduce the risk and potentially the loss of life occurring as a result of dam-related hazards. Our goal is to elevate dam safety practices on a national level to the point where risks are effectively and strategically conveyed to patrons. Through thorough dam risk evaluations, consistent, effective, and clear communication practices, and a regular sign, assessment, and maintenance program, dams can help change patrons' risky behaviors. Thanks for your time. The team understands the importance of our efforts and is thrilled that we have a place in making dams safer. Please join us for the live Q&A immediately following, where our team will be available for questions and comments. Thank you very much.
Great presentation, Jim and Diane. Thanks. We have both Jim and Diane here to answer any questions that you might have. In addition, Preston Wilson, who's with the FEMA National Dam Safety Program, has joined and is available to help answer any questions you might have as well. So, folks, go ahead and send in your questions, and we'll get those answered.
Well, I guess while we're waiting for some questions, I just wanted to highlight the importance of dam signage and public awareness of dam risk. I recently heard a statistic that there have been more fatalities due to user error than there have been from dam breaches altogether. And I went and did some research. I found the ASDSO website, and there have been quite a few deaths per year at dam sites around the nation. In 2019, there were 57. In 2020, there were 38. And so far this year, there have been 8, and the season's just getting started. So I think we need to do a better job at educating the public about some of these risks around dams. I mean, things might look benign and, you know, calm with the waters at the surface, but as soon as you know, go underwater, you can hit that turbulence and really get into a pretty serious situation very fast. So.
Yeah, thanks, Diana. Those are good statistics, and yeah, it is a really important effort. I see a couple of questions in the chat. Did we find any major differences between signs with graphics versus signs with language, or a combination of the two? Our goal is to have the combination. We will have graphics, pictograms, and then language, you know, verbiage or text. And typically, you know, they go together. I would say somewhere down the road, possibly you could just have a pictogram, because people would be more familiar with it. But, you know, going in, our recommendations are going to be, you know, to have them as a pair.
Thanks, Jim. Another question in there about the signage. Will only be placed on or adjacent to the dam itself? Any plans on creating dam failure zone or evacuation zone signs that can be placed miles from the dam by the local emergency management staff as part of a public safety outreach effort, much like the NWS signage for roadway flood areas?
You want to take that one, Jim?
Sure. Yeah. Okay. So we will have considerations for signs outside of, you know, the dam property. Obviously, that will have to be coordinated with, you know, local authorities, because, you know, dam owner operator doesn't necessarily have, you know, any authority to put a sign, you know, upstream or downstream from the dam itself. So, you know, we will have signs that would be, you know, risk of rising water, you know, quickly rising water and things like that, that may not be physically right on the dam site. But again, you know, we can't require, let's say, an adjacent landowner to put up a sign. That would have to be something that would be coordinated locally. Any other comments, Preston or Diana?
No, I think you got it. I think, yeah, it's that coordination and those agreements that are going to need to be worked out between all the stakeholders to get that signage where it needs to be.
Yeah, no less important. I think those signs are important in those areas, but it's that coordination that has to be worked out.
Mm-hmm.
Okay. We got another question here about funding. Is funding available for dam improvements from FEMA, EPA, others?
So I guess I'll take this one. Yes, there are a combination of funding, but they all have their different requirements and have the different eligibility requirements for each one of those different elements. We definitely started a new program a couple years ago called the High Hazard Potential Dam Rehabilitation Grant. That is funded out of FEMA for the first couple of years. We're doing non-construction projects, so pre-construction projects for that work. NRCS has programs for their dams. There's some state dam programs. So there's different programs out there for different types of dams. So it takes a little bit of research to kind of understand what program might be eligible for those dams in your community.
Thanks. Another question here about sign standards. Are there no sign standards now? Is there an effort to develop a standard?
I'll let one of you go, and I can.
Okay,
right.
I'll go.
Go ahead, Diane.
So in North America, in the United States, we don't currently have a national standard for the United States as far as dam-specific signage goes. We did look at some. The Canadian Association of Dams has some guidance up there, and we looked at other resources like the Department of Transportation and other sources like the Army Corps of Engineers and the Bureau of Rec to look at what signage is there. But there's nothing universal that you need something that's very recognizable, very well understood, hopefully nationally. So we are working on a guidance document for FEMA, and we hope to have it out early fall. So be looking for that.
Yeah, not a lot to add there, but that's one of the things that that brought this effort on. They wanted some consistency nationally, and so that's why we don't really FEMA, we don't really create standards. We give the industry guidance, and so that's exactly what we're doing. We're starting off with this best practices guidance, and then we might even build off of this document in the future. Based on the industry needs. So hope that answers your question.
Thanks, everybody. Any other questions out there? We have just a minute or two if there's any other additional questions. Any other questions? All right. All right, seeing no other questions, I just want to thank everybody, all our presenters. Fantastic job, really interesting presentations. I hope everybody enjoys the rest of the conference, and you will we'll sign everybody off. Thanks, everybody.